It begins in the dark, a sky so wide it forgets its edges, a silence so old it hums. Somewhere inside this quiet, a single question flickers like a distant lighthouse. How many universes exist? Not how many stars or galaxies or clusters stitched into filaments, but how many entire stage sets of reality, how many separate renditions of physics, time, and meaning. Through one lens, the night is a black ocean, and this cosmos a single wave cresting and falling. Through another, reality is foam, countless bubbles blooming out of a deeper sea, each with its own chemistry of laws, its own histories, its own ways for matter to become memory. And underneath, in the deepest current, quantum theory whispers that every choice, every measurement is not an ending but a branching, an orchard of histories unfolding where certainty once stood. Astronomy calls for patience, physics requires nerve. The question of how many is not a census, it is a pressure on the mind. It forces the gaze past the observable, beyond the light that has had time to reach us. It asks whether infinity is merely a convenience of equations or the actual scaffolding of existence. If there are other universes, do they touch this one? Do they rhyme with it, diverge from it, or remain forever sealed behind horizons that no signal can cross? If there are none, why does this one possess the numbers that let stars ignite and minds awaken? He will listen to the fossils of light. She will measure the newborn ripples of space-time. They will argue about probability in an infinity where everything that can happen does. And the night will keep humming. Because to ask how many universes exist is to ask what kind of thing reality is, and whether this cosmos is an only child, or merely the one that learned our names. A century ago, the universe on paper preferred stillness. Equations could bend and permit motion, yet minds trained on celestial clockwork hesitated. General relativity had opened the floorboards beneath Newton's steady house. Curved spacetime allowed solutions that breathed, expanded, and curved back upon themselves. But a static cosmos felt safer, and even Einstein briefly furnished his field equations with a cosmological constant to hold the heavens in place, like a hidden brace behind a painted set. The sky, however, had already begun to walk away. At Mount Wilson in the 1920s, a mirror the size of a small room gathered the shy light of spiral nebulae. Distances were coaxed from Cepheid variables, pulsing stars that Henrietta Leavitt had turned into standard candles, and velocities were pried from the tilt of spectral lines. Earlier, Vesto Slipher's patient plates at Lowell Observatory had revealed that many spirals were sliding redward, as if carried outward by a current. In 1929, Edwin Hubble plotted distance against recession speed and found a line angled toward astonishment. Galaxies were not drifters in a tranquil sea. Space itself was stretching, and with it everything adrift upon it. The relation, velocity proportional to distance, read like a stage direction written into geometry. The farther the actor, the faster the retreat. Cosmology turned from a painted backdrop into a moving scene. In the wake of that motion came an afterthought of fire. Two radio engineers at Bell Laboratories in Holmdel, New Jersey, tuned a horn-shaped antenna to the sky in 1965 and found a stubborn hiss that would not yield to engineering. Pigeons were evicted, nests cleaned, the instrument recalibrated, and still the noise remained, an all-sky whisper with the temper of a temperature. Across the river at Princeton, theorists had been preparing an ear for exactly such a sound, the fossil heat of a universe once hot and dense, cooled by expansion into a microwave glow. The measured excess, near 3 Kelvin, matched the expectation of a cosmic afterglow. What began as an annoyance in a radio system became the most democratic light in existence. The cosmic microwave background, arriving from all directions with near-perfect uniformity, an orphaned memory from when the cosmos first became transparent. Its present temperature, later refined to about 2.725 Kelvin, pinned the story to a hot Big Bang and set the tone for the questions to follow. Uniformity that perfect was not entirely welcome. If different parts of the early universe had never been in causal contact, how did they agree so precisely on their temperature? Why was space so nearly flat when curvature could just as easily have been wild? And where did the seeds of structure, the tiny irregularities that would later grow into galaxies, first arise? In 1981, Alan Guth proposed a radical prelude, an era when a peculiar form of energy drove the universe to expand exponentially fast, smoothing and flattening everything within sight. In that brief, violent exhalation, any initial wrinkles were ironed out, and quantum jitters were stretched into cosmic imprints, later to be seen as faint, 1 part in 100,000 ripples in the microwave background. Inflation answered the horizon and flatness problems with one gesture and offered a mechanism for the origin of structure. It did more than fix the stage dressing, it rewrote the opening scene. But the new prelude brought an unexpected overture. In many versions of inflation, the process never ends everywhere at once. It finishes locally, here, then there, while elsewhere it continues, like boiling water where bubbles of steam nucleate within a still simmering pot. Each bubble cools, reheats, and evolves with its own initial conditions. Quantum fields choose different vacuum states and symmetry breakings. The constants that govern chemistry and stars might vary. The global spacetime keeps inflating, and within it, islands of post-inflationary universes bud without end. The picture took the word universe, once singular, and made it regional. A single cosmic history became a mosaic of histories, separated by inflating gulfs no signal could cross. Even abundance must answer to origin. If inflation can continue forever toward the future, can it have stretched infinitely into the past? A theorem by Arvind Borde, Alan Guth, and Alexander Vilenkin argued against an eternal regress. Under very general conditions, any spacetime that is on average expanding must be geodesically incomplete to the past, meaning the inflationary movie, run backward, reaches a boundary where its description fails. The multiverse, if it blossoms forward without end, still seems to require a seed. The stage for multiplicity does not dissolve the question of beginnings, it sharpens it, drawing a line where current physics must hand the script to deeper ideas. While cosmology learned to speak in plural, quantum theory quietly suggested a different path to multiplicity. In 1957, Hugh Everett proposed a formulation in which the Schrödinger equation never breaks. Measurement, in this view, is not a collapse of possibility but a branching of it. Systems become entangled with apparatus, apparatus with environment, observers with outcomes, and decoherence renders the branches effectively non-communicating. All outcomes permitted by the wave function occur, but not together. They unspool along separate, mutually inaccessible strands. This relative state picture did not add new machinery. It withdrew an assumption, the collapse postulate, and paid for it with an audacious ontology. Here, the plurality does not live beyond horizons in distant space. It abides in the bookkeeping of quantum events, layered within the very theater where one universe already unfolds. What began with a line on a Mount Wilson graph and a hiss in a New Jersey horn now pressed into a deeper grammar of reality. The discoveries were not unrelated stones laid end to end. They formed an arch that carried new weight. Expansion introduced a universe with a past. The microwave background made that past hot and shared. Inflation made the origin smooth and seated. Eternal inflation hinted that cosmos might be local parlance. The Borde, Guth, Vilenkin boundary reminded the story that even multiplicity needs a first page. Everett's branching reframed how many as a question with layers. Bubbles across a grand inflating expanse. Branches within the quantum weave of any given bubble. Evidence sharpened as instruments matured. The microwave background, once identified as a nearly perfect blackbody, became a canvas for fine structure. Anisotropies at the level of tens of microkelvin, mapped first by Kobe, then with crisp detail by WMAP and Planck. Their harmonic peaks, like the resonance of a drum, encoded the composition and geometry of the cosmos and confirmed key predictions of a hot Big Bang with inflationary seeds. Yet the features that would discriminate among the many species of inflation, Primordial gravitational waves, or subtle non-Gaussianities, remained elusive, deferred to more sensitive detectors and cleverer analyses. The discovery phase thus did not end with discovery. It widened into a program. Each new dataset refined the opening claims and left the most daring implications: plural universes, a boundary at the beginning, branching worlds, suspended between inference and proof. People often speak of discovery as a moment, and sometimes it is a plot of points that refuses to be random, a stubborn noise that will not wash away. But in cosmology, discovery is an accumulation of fidelities. A redshift distance law invites a new cosmography. A skywide glow fixes a hot start. A short, inflating prelude solves ancient puzzles and introduces a universe of universes. A theorem draws a frontier on the map. An interpretation of quantum mechanics suggests that multiplicity may be already at hand, everywhere and always, without any need for new space beyond. The result is not a riot of claims but an economy of ideas, where each observation obliges theory to fit closer, and each theory, to be science, must tease out something the sky could in principle reply to. Under that gravity of evidence and restraint, the question that opens the night, how many universes exist, acquires both dignity and treachery. It will not be answered by counting galaxies or by cataloging their light. It demands an understanding of what counts as a universe, and under what rules. The discovery phase, taken in whole, does not announce a census. It composes a field guide to possibilities. Some live in distant pockets of an inflating whole, some in the branches of wave functions rendered mutually silent by decoherence, some, perhaps, in mathematical structures not yet disciplined by measurement. Each candidate must be tied, however lightly, to the cloth of observation, to the flatness of space, the lacework of large-scale structure, the statistics of microwave ripples, the absence or presence of primordial gravitational waves, the logical demands of quantum theory. The turning of cosmology from static dreams to expansion opened the gates to this field guide. The afterglow of the first light made those gates empirical. Inflation suggested the path leads through many gardens. A theorem planted a sign that says, origin still required. And an interpretation of quantum mechanics suggested that multiplicity is not only a cosmological prospect, but an intimate feature of the way reality computes outcomes. In the half-light of these discoveries, the universe becomes both more intelligible and more strange. The sky, once a dome, becomes a rehearsal hall where several kinds of plurality practice their lines. The script remains incomplete, but the first acts are clear. They are written in recession speeds and blackbody curves, in the cadence of acoustic peaks and the logic of geodesics, in the mathematics of fields and the silence between branches. Discoveries that turned a single stage into a layered theater and made the counting of universes not a boast, but a discipline. Shock entered not with thunder, but with arithmetic that would not behave. Expansion had already made the visible world an island whose shoreline was a horizon, and inflation extended the archipelago beyond sight. Yet the deeper jolt came from what those horizons implied. If inflation did not halt everywhere at once, then regions cooled into pocket or bubble universes while the background kept ballooning. In such a spacetime, there were not merely more galaxies than could be counted, but more domains than could be compared, each with its own initial conditions, perhaps even its own low-energy laws. The old word universe, once meaning all that exists, had to be demoted to mean our observable patch. Language stumbled, ontology followed. The first tremor was conceptual. Infinity acquired agency. In an unending expanse where bubbles form without bound, every arrangement allowed by the underlying theory occurs somewhere, not once, but arbitrarily many times. Rarity vanishes. Typicality becomes the only question worth asking. If enough space exists with the same laws, then far beyond the horizon, so far that light would never bridge the distance, there must be regions arranged almost exactly as this one, and others where the cosmic dice landed differently. With that recognition, cosmology crossed from singular history into ensemble thinking. The map no longer promised a unique itinerary, it presented a distribution of worlds. Then came the second tremor, orthogonal to the first. Quantum theory, stubbornly unitary in its mathematics, suggested that multiplicity might not require distant bubbles at all. If the wave function never collapses, if measurement is only the knitting of systems into larger entanglements, then outcomes separate by decoherence rather than annihilate by choice. The many worlds implied by this stance do not inhabit other pockets of space. They are different branches of the same universal state, rendered effectively non-communicating by environmental entanglement. Together, eternal inflation and quantum branching created a perpendicular geometry of plurality, a vast garden of bubbles across space, and an interior grove of branches within any one bubble. The count, already dizzying, acquired depth. But it was probability that detonated the real surprise. Prediction in science relies on comparing the likelihood of outcomes. In a laboratory, frequencies converge as experiments are repeated. In an eternal multiverse, repetition is guaranteed in the most extravagant way possible. Everything that can happen does, and infinitely often. How, then, to define the fraction of observers who see outcome A rather than outcome B? To compute frequency in an infinity requires a measure, a prescription for trimming the boundless set into a sequence that can be compared. Different measures, different ways of ordering or regulating the infinite, produce different typical predictions. A theory once thought to be richly predictive threatened to become hostage to bookkeeping. The dilemmas took names. Cutoffs introduced paradoxes in which younger pocket universes dominated the census, predicting skis far hotter than observed. Attempts to count by geodesics or by stationary watchers shifted the paradoxes rather than erasing them. In some prescriptions, observers assembled by rare fluctuations in a quiet, late-time de Sitter space. The notorious boltsmen, observers like those born in galaxies after stars and chemistry have had time to work. If such pathological counts prevailed, typical experience would be thermal nonsense, not structured world. A defensible cosmology had to suppress such outcomes, either by insisting that the inflating background decays fast enough or by choosing a measure that renders freak observers negligible. The shock was not merely philosophical, it was existential. It forced cosmology to define what it meant by observer and prediction, to ensure that a universe hospitable to life did not drown in its own infinities. Meanwhile, the constants of nature staged their own revolt. Gravity's measured strength, the mass of the electron, the ratio of matter to radiation, values that appear contingent rather than necessary, seemed exquisitely arranged for complexity. Above all stood the small, positive vacuum energy density that today drives accelerated expansion. If it were much larger, structure would never condense. If much smaller and negative, the cosmos would recollapse before stars matured. The observed value, so tiny in natural units it defies naive quantum estimates by staggering orders of magnitude, sat near the threshold that still permits galaxies. In a multiverse that samples a wide range of vacuum energies, observers would most often arise where that threshold is barely met. The anthropic argument, avoided for generations as a last refuge, stepped into the bright center of the stage not as explanation, but as selection effect. If there are many domains, most observers see a vacuum energy small enough to allow structure, but not smaller than it needs to be. The scientific shock lay not in invoking life as a premise, but in admitting that data alone might never tell whether the constant's value is unique or environmentally chosen. Empiricism pushed back. If inflation cranked the universe into such smoothness, it also stretched quantum fluctuations in spacetime itself, potentially leaving behind a curl pattern, B-mode polarization, in the cosmic microwave background. The search for this pattern became a pilgrimage. An announcement of detection arrived like a trumpet, promising a smoking gun for gravitational waves from the earliest moments, only to find, upon deeper analysis, that interstellar dust could mimic the signal all too well. The correction was not a defeat but an admonition. The early universe would yield its signatures only under strict interrogation, across many frequencies and instruments, with foregrounds and systematics caged. Even here, the shock did useful work, reminding the field that the path from bold idea to secured evidence passes through rigor tighter than romance. What made the phenomenon terrifying was not monsters beyond the map, but a challenge at the roots of method. Science thrives on phenomena that can be compared, repeated, and cross-checked. Yet the multiverse, whether across bubbles or branches, hides its distinctions behind horizons or decoherence barriers. The evidence most directly accessible, microwave anisotropies, the web of galaxies, the dimming and brightening of supernovae, speaks about the physics of this domain and this branch. The inference to a broader ensemble is indirect, riding on the internal coherence and graceful success of theories like inflation and quantum field theory. How much weight could be placed on an inference whose rivals are not new observations but new priors? Even the meaning of identity bent under the load. If sufficiently large domains ensure exact or near-exact duplicates, then biography becomes a local property rather than a universal one. Somewhere unimaginably far away, within physics that mirrors this one, another history may have solved different equations of chance. Within many worlds, duplicity goes from spatial fantasy to formal necessity. The same experiment branches into incompatible outcomes, each realized, each with its own record, each carried forward by decoherence's arrow. Personhood takes on the character of a world line that splits, not a soul that shifts. Such reflections belong to philosophy, yet they were not invited by whim. They were smuggled in by the algebra of the theories most trusted to describe the world. Still, the shock did not invalidate the endeavor. It clarified it. If prediction depends on measure, then the measure problem is not an embarrassment to be hidden behind rhetoric, but a research program to be solved. If anthropic reasoning seems distasteful, then devise theories that predict unique low-energy parameters or observables that discriminate among landscapes. If bubble collisions sometimes leave imprints, concentric circles, cold or hot spots, then comb the microwave sky for the faint geometries they would trace. If many worlds is a rephrasing of the same unitary dynamics tested daily in laboratories, then accept that the interpretation will not be settled by a single decisive experiment, but by the economy and coherence with which it organizes what is already known. The greatest rupture was temporal. A theorem showed that even if inflation expands without end toward the future, the road backward is finite. Past incompleteness means a boundary where the classical story stops. The multiverse, if it exists, is not a replacement for origins but a new frame in which origins still matter. That boundary concentrates the questions. What set inflation going? What selected the potential? What started the quantum state? The shock, in other words, pulled attention not only outward to multiplicity, but inward to beginnings, not only to how many universes there could be, but to how any universe begins to be. Across observatories and blackboards, the field adapted. It learned to speak cautiously about evidence and ambitiously about frameworks, to separate the untestable from the not yet tested. It learned that infinities are not decorations but engines. Mishandled, they destroy prediction. Handled correctly, they refine it. It learned to wear humility like a tool belt. No one instrument would settle the question, but a suite of them. Microwave polarization, large-scale structure, supernova cosmology, gravitational lensing, even atom-scale tests of quantum mechanics, could box the possibilities into narrower corners. It learned, finally, that how many universes exist is not a demand for a numeral, but for a theory that decides what counts as a universe and how to weigh them. In the quiet after the shock, one perception remained. The terror was not of too many worlds, but of too little method. The remedy would be patience hardened into strategy. The strange, paradigm-breaking features, the plural domains, the branching outcomes, the tyranny of measure, the subtle role of selection, did not stand outside science. They redefined its frontier. The universe still hummed with the same microwave afterglow. Galaxies still moved on the same expanding stage. But the question had changed shape. It was no longer whether there are other universes in the casual, speculative sense. It was whether the theories that demand them can be nailed to observables in this one, and whether, once nailed, they leave any freedom for denial. That transformation, the migration of plurality from rumor to requirement, was the true scientific shock. The inquiry turned from revelation to craft. Discovery had opened a door. Investigation began to tune the light that passed through it. The relic afterglow, once an annoyance in a radio receiver, became a ledger written across the sky, and instruments were built to read its smallest entries. The arc of effort was long and deliberate. From a satellite that first confirmed the uniform warmth of creation, to experiments that chased ripples so faint they hid inside a few tens of microkelvin, to collaborations that learned to hear the whisper of polarization twisting in the oldest light. The mystery of multiplicity would not be settled by metaphor. It would be pursued by maps. The first map was coarse, and that was enough to change the stakes. A satellite measured the cosmic microwave background to be a nearly perfect blackbody and revealed slight variations in temperature across the sky. In those blotches, just 1 part in 100,000, lay the fossil of quantum fluctuations stretched to astronomical size. A procession followed. One mission drew finer contours. Another resolved acoustic peaks in the background's power spectrum, harmonic signatures of a young plasma ringing under gravity and pressure. The positions and heights of those peaks, certain intervals amplified, others subdued, spoke of matter and radiation, of baryons and dark matter, and of a geometry nearly flat. Statistics of the sky became a registry of the cosmos content, and in those statistics, inflation's handwriting appeared. A nearly scale-invariant spectrum, not perfectly flat but tilted, consistent with an origin in quantum fields coupled to a brief, superluminal swell. Yet the imprint that would most decisively signal inflation's violence remained elusive. If spacetime itself had rippled when the universe was younger than any clock can discriminate, those ripples would have impressed a curl, B-mode polarization, into the microwave background. The search for B-modes became a discipline in asceticism. Telescopes gathered in the dry cold of high plateaus and polar deserts. Detectors counted photons as if counting grains of snow in a storm. An initial trumpet call was tempered by dust, the galaxy's magnetic fields aligning interstellar particles to polarize foreground light in a way that could mimic the very signature sought. The correction was a lesson in patience, and the campaign recalibrated. Multi-frequency surveys to separate sky from soot, better delensing to strip away polarization induced by intervening structure, more seasons of data to trade excitement for certainty. Negative results were not empty. Each upper bound cut the space of inflationary models, excluding the simplest large-field scenarios and forcing theory towards subtler potentials. If the microwave sky was the baby picture, the grown universe's skeleton would provide a second witness. Galaxies moved into focus not as ornaments but as tracers of the underlying matter. Redshift surveys swept the heavens, recording positions and distances for millions of galaxies. Within those maps hid a standard ruler, the baryon acoustic oscillation scale, the frozen remnant of sound waves from the primordial plasma. Measured at different cosmic epochs, that scale traced the history of expansion, confirming an acceleration that had first been inferred from the light curves of distant supernovae. In the quiet geometry of those measurements, the role of vacuum energy, however named, whether as a cosmological constant or something more volatile, was fixed more tightly into the equations that evolved the sky. Where galaxies failed to tell the whole truth, the bending of light completed the sentence. Weak gravitational lensing, subtle distortions in the shapes of distant galaxies due to the tidal fields they traversed, provided a way to weigh the invisible. Sheer maps stitched across thousands of square degrees revealed the growth of structure over time. A parameter that combined the clustering strength with the matter density became a focus of attention, not for its artistry but for its tension. Values inferred from late-time lensing and clustering surveys sometimes leaned lower than those projected from the early universe's acoustic testimony. The discrepancy did not yet demand new physics. It did insist on scrutiny, of systematics in ground-based imaging, of photometric redshifts, of baryonic feedback marring the clean physics of cold, dark matter. If the tension held or sharpened, it would be a thread to pull. If it relaxed, it would be a certificate of the standard model's resilience. Either way, the count of universes would not be settled by this alone, but the health of the model that hosted the question would be. The microwave background had more to say than temperature. Polarization patterns, E modes sourced by scalar perturbations, B modes sourced in part by lensing and perhaps by primordial gravitational waves, added orthogonal handles on the initial conditions. Cross-correlations between temperature and polarization tied reionization, lensing, and primordial physics into a coherent weave. A reconstruction of the lensing potential from the background's own small distortions provided a map of the intervening matter and an independent measure of structure growth. Non-Gaussianity of the primordial fluctuations, if present, would have betrayed unusual inflationary dynamics or extra fields. The sky returned limits that pressed models toward simplicity. At the largest angular scales, anomaly flirted with significance. A quadrupole lower than naive expectations, alignments of low multipoles along curious axes, hints of hemispherical asymmetry. Each feature examined fell short of a verdict. Cosmic variance, the fact that the universe offers only one sky to sample, ensured that the biggest features would be forever a small number game. Chance could not be entirely excluded. Interpretation could not be entirely satisfied. These irregularities occupied the borderland where theory and statistics shake hands without quite agreeing whom they have met. They did not prove a multiverse. They did not disprove it. They set the temperament of certainty that would be required for any claim of such scope. If eternal inflation had bubbled, could two domains have collided early enough to scar the background? The question moved from poetry to templates. Analysts searched the microwave maps for concentric rings, for step-like discontinuities, for disk-like modulations that might betray a past encounter across an inflated gulf. The results were conservative. No compelling evidence, constraints placed on the amplitude and frequency of such events. But the method mattered. It demonstrated that even ideas born in the wilds of theory could, with discipline, be led into the field and tested against data. A failure to find scars did not erase multiplicity. It fenced one class of its possible signatures. Investigation reached beyond cosmology's grand canvases to its quantum loom. If multiplicity also arises within the quantum formalism, as branches rendered effectively non-communicating by decoherence, then the relevant laboratory is not the sky, but the interface where systems meet environments. Experiments pressed coherence to larger masses and longer times. Molecules interfered with themselves. Superconducting circuits displayed superpositions of macroscopic currents. Mechanical resonators tiptoed toward regimes where vibrations of visible objects maintained phase. None of these devices could peak between branches or violate unitarity. Their value lay in the relentless confirmation that the Schrödinger equation holds wherever it is tested, and that collapse, if it occurs, leaves no trace outside the story told by entanglement and environment. It was not evidence for many worlds. Interpretations do not bend instruments quite so easily, but it was pressure against ad hoc modifications meant to restore uniqueness to outcomes. In the absence of collapse, multiplicity shadows every measurement whether one names it or not. The deeper the data sank into detail, the more the investigation learned to distrust easy victory. Foregrounds, dust, synchrotron free emission, mimicked cosmological signals in the microwave sky. Surveys learned to span many frequencies and model the galaxy as carefully as the cosmos. Instrumental systematics disguised themselves as physics. Collaborations answered with cross-checks across platforms, seasons, and scanning strategies. Theories learned to be vulnerable, stated with parameters that experiments could wound. The question of how many remained abstract, but the scaffolding on which any answer would rest grew specific and hard. Attention turned, too, to curvature and topology, properties that would betray the universe's global character. Measurements pressed spatial curvature ever closer to zero, leaving little room for a non-Euclidean cosmos on large scales. Searches for matched circles in the microwave background, the hallmark of a multiply-connected topology, returned null. Infinity could not be confirmed by maps of a finite sky. Finitude could, in principle, be detected if space wrapped back on itself within the observable domain. It did not. The absence of such signatures kept the default simple, a flat, effectively unbounded geometry consistent with inflation's broadest strokes. Meanwhile, the census of the universe's ingredients matured, and with it, the understanding of what could be asked. The number of effective relativistic species during nucleosynthesis and recombination, an index sensitive to the sea of neutrinos, aligned with expectations. The damping tail of the microwave power spectrum, the thickness of the last scattering surface, and the imprint of lensing together constrained deviations from the simple picture. The helium fraction, the deuterium abundance, and the light element yields tied the fireball at seconds to the afterglow at hundreds of thousands of years. Each coherence added weight to a model in which inflation seeds structure, dark matter scaffolds it, and vacuum energy accelerates the late-time expansion. In that secure scaffolding, the pathways to testing multiplicity remained narrow but not invisible. Inflation's dynamics could be further cornered. Better limits, or a detection, of primordial B-modes would measure the energy scale of the earliest moments and guide which classes of potentials, and which classes of eternal behavior, are viable. Searches for isocurvature modes would probe whether more than one field participated in the initial swell. Non-Gaussianity limits, tightened by polarization, would either keep the simplest single-field models safe or rule them unambiguously thin. Large-scale structure, mapped deeper and wider, would continue to squeeze models, freedom to diverge from the standard tail without notice. Beyond instrumentation, the mathematics of infinity demanded its own investigation. The measure problem of eternal inflation, how to define probabilities in an ensemble where everything occurs infinitely often, learned to speak the language of regulators and cutoffs, of stationary distributions and geodesic averages. Competing proposals were tested not with telescopes, but by their capacity to avoid paradox and to reproduce observed regularities without smuggling those regularities into the premises. A viable measure would suppress pathological observers conjured from thermal noise and would not predict skis radically unlike the one that exists. In this domain, rigor assumed a different face, no less exacting, no less mathematical, and no less bound to the requirement that a theory which multiplies worlds must, at minimum, make a world like this one unsurprising. The investigation, then, was double, outward to the earliest light and the largest structures, inward to the logic that weighs infinities without losing sense. The two fronts were not isolated. A map of polarization could prune inflationary potentials, shrinking the set of eternally inflating scenarios. A coherent measure could turn a giddy ensemble into a calculus that returns numbers rather than shrugs. In both, the same ethic prevailed. Abstain from statements that cannot, in principle, be confronted by observation or consistency. Pursue those that can with an obstinacy that outlasts fashion. Night by night, the sky offered its steady hum. Instruments inhaled the thin air of deserts and plateaus, mirrors cooled, electronics counted, algorithms learned to suspect their own enthusiasm. A field accustomed to the drama of firsts accepted the duty of seconds and thirds. Repeated measurements, improved calibrations, overlapping surveys. What the deeper investigation revealed was not a headline but a posture, the willingness to let even the most speculative architecture be interrogated by light, by lensing, by the shapes of galaxies and the curl of ancient polarization, by the strictures of statistics and the sanity of measures. The mystery did not recede. It acquired contours. It learned the cost of being asked seriously. And in that cost lay its only chance of an answer. The mystery did not simply widen, it steepened. What began as a revision of the map, the universe expanding, the afterglow singing of a hot birth, became a revision of the rules for making maps at all. The more precisely the sky was read, the more the question, how many universes exist, pressed into the joints of theory, where infinities awaited with the patience of stone. Empirical success did not soften the terrain, it made the cliffs more obvious. Every new constraint tightened the circle around a conclusion that, if accepted, would alter what was meant by explanation. A first escalation arrived in the suggestion that laws themselves might be regional. In high-energy theories that attempt to unify forces and particles, the menu of low-energy worlds is not singular. Extra dimensions, curled into shapes too small for light to explore, furnish different possibilities for symmetry breaking and vacuum energies. Fluxes thread those shapes, moduli settle into minima. Each choice seeds a distinct effective physics. The catalog is not a handful but a library, an enormous landscape of metastable vacua. If inflation samples that landscape, budding pockets where fields tumble into different valleys, then how many ceases to be a countable curiosity? It becomes a distribution over universes, each with constants fixed not by inevitability but by environment. The most stubborn constant of all, the small positive vacuum energy that now accelerates expansion, slides into focus under this lens. Its measured value, fantastically smaller than naive quantum estimates, hovers near the threshold that still permits galaxies to form before expansion tears them apart. In a landscape, such a value is not singled out by equation alone. It is filtered by habitability. The success of that selection is uncomfortable because it reads like an admission. Some parameters might be typical rather than necessary. A second escalation arose from the arithmetic of infinity. Eternal inflation multiplies domains without bound. Quantum mechanics, in its unitary interpretation, multiplies outcomes without erasure. Prediction, which in a finite laboratory means comparing relative frequencies in repeated trials, becomes treacherous when everything that can happen happens, infinitely often. A measure is required, a rule to regulate the infinite ensemble so that typical can be defined. But measures are choices, and choices disagree. Global cutoffs bias toward youth, because exponentially growing volumes are dominated by freshly formed pockets. Local prescriptions track geodesics or watch from stationary world lines. Each avoids certain paradoxes only to invite others. In some naive counts, observers congealed from thermal noise in a cold, late-time de Sitter space. The notorious Boltzmann brains swamp those born through astrophysical history. A viable measure must exile such pathologies, not by decree but by dynamics or regulation that render them negligible. The need to police absurd observers is not a sideshow. It is a sign that the line between physics and probability theory has become a load-bearing wall. The third escalation was methodological. Horizons born of acceleration restrict what can be checked. An event horizon in a lambda-dominated cosmos makes distant regions forever out of contact. Even light launched now will not bridge the growing gulf. Bubble universes beyond that horizon, if they exist, are not merely far. They are censored by the geometry itself. Quantum branches, if they exist, are not merely unvisited. They are separated by decoherence into histories that cannot be recombined by any feasible operation. The ordinary discipline of science, replicate, exchange, compare, encounters principled limits that are not technological delays but features of the world. The field adapted by asking only what could in principle be inferred from internal consistency plus local data. It did not bow out, but the margin for triumph narrowed from spectacle to nuance. Identity and typicality became instruments as important as telescopes. In a single finite Hubble volume drawn from an effectively infinite space, there are regions statistically identical to this neighborhood at distances far beyond any reach. In a branching quantum cosmology, there are histories with records and memories that match this one up to a point and then diverge. Self-locating uncertainty, the question which copy is this, is not whimsical. It is a coordinate in the problem. Any attempt to weigh hypotheses about ensembles must specify how an observer's indexical information enters the likelihoods. The act of being somewhere becomes part of the data, not metaphysics draped upon it. This is science with mirrors at the edge of the frame, the reflection unavoidable, the camera visible in the shot. Meanwhile, the ground under eternal inflation shifted. Within quantum field theory coupled to gravity, de Sitter, like states are subtle. Some arguments suggest that fully stable de Sitter vacua may be difficult to realize in consistent theories of quantum gravity. Others produce constructions meant to evade that pessimism. The debate does not yet settle the sky, but it raises the cost of certainty. If long-lived accelerating vacua are scarce or absent, then the global picture of endless bubbling needs revision. If they are plentiful, then the measure problem carries even more weight. The escalation cuts both ways. Either the mechanism is fragile and must be nailed precisely, or it is robust and must be regulated carefully. Closer to home, the Higgs field's measured mass and the top quark's mass place the standard model near a boundary between stability and metastability of the electroweak vacuum. In simple extrapolations, the current vacuum could be long-lived but not ultimate, separated from a deeper state by a barrier thin enough that, under rare quantum fluctuation, a bubble could nucleate and race outward at almost the speed of light, rewriting the rules inside it. This is not a forecast, it is a portrait of proximity in parameter space. Yet as metaphor it is exact enough, even one universe can sit on a ledge. In a multiverse, ledges are common. Landscapes are made of them. Empirical campaigns sharpened frames while enlarging doubts. Spatial curvature was pressed closer to zero, narrowing the room for exotic topologies that wrap within the observable sky. Non-Gaussianity constraints were tightened, chastening flamboyant multi-field models of inflation. Limits on primordial gravitational waves trimmed entire families of potentials and pushed the favored energy scale lower than many had dreamed. Each no was an escort toward a more austere yes. Yet the absence of decisive B modes, the resilience of the simplest, nearly Gaussian scalar perturbations, and the discipline of a lambdictum background left open both roads. A universe that inflated without the eternal tail, or one that did but hides its multitude behind absence of scars, safe measures, and quiet parameters. Escalation here is not a crescendo of evidence for multitudes. It is a crescendo of dependence on things that are difficult to test. Even where hints of inconsistency appeared, they conspired to be modest. Late-time measures of the growth of structure sometimes leaned lower than projections from the early universe's portrait. The Hubble constant, estimated using local distance ladders, strained against the value inferred from the microwave background under standard assumptions. If those tensions had cracked wide, they might have signaled new physics with an appetite for radical renovation. Instead, they hovered at the margins of credibility, subject to systematic suspicion. Escalation took the form not of scandal but of stamina. Surveys extended, calibrations deepened, telescopes prepared to overwrite the arguments with new baselines. The mystery did not need crisis, it only needed endurance. Within the quantum reading of multiplicity, the deepening took a different color. Decoherence, quantified and traced, showed how quickly superpositions surrender interference when braided with environment. Pointer states emerge, records stabilize, and the classicality of macroscopic objects becomes an emergent, context-sensitive property. No apparatus yet pries apart branches or reweds them. The mathematics says such surgery would require control that grows exponentially with degrees of freedom. The implication is not proof of many worlds. Interpretations do not flash their credentials on detectors. The implication is that unitarity rules wherever it has been tested, and the cheapest ways to modify it to avoid branching conflict with equally cherished symmetries or with experiments that would have noticed. The escalation here is ethical. If adding collapse salvages uniqueness only by introducing new, unobserved dynamics, then the burden of proof shifts. A quiet ontology gains the presumption. With each turn, the mystery became more intimate. To ask how many universes exist was no longer to survey imaginary archipelagos, but to reckon with how physics secures meaning. If laws can be environmental, then explanation includes selection effects as well as derivations. If probabilities require measures, then prediction includes a prior about how to weigh places and branches. If horizons censor, then testability includes an acceptance of what can be inferred only indirectly. The threat, if any, was not to the existence of truth, but to a simpler picture of how truth is established. Yet the deepening also clarified where light could still enter. A detection of primordial B modes at a level corresponding to a high inflationary energy scale would favor large field dynamics and strengthen the case that inflation, if it occurred, sampled enough field range to make eternality plausible in many models. A sharp non-Gaussian signature would point to additional fields active during the swell, changing how bubbles form and what they contain. Improved maps of weak lensing and galaxy clustering across cosmic time would narrow the space in which dark energy can vary, pressing either toward a strict cosmological constant or toward dynamics that complicate the late-time horizon. Even null results instruct. Each tightened limit prunes ensembles of worlds that would have left louder fingerprints. The escalation, then, is not a plot twist but a pressure test. The more carefully the one observable universe is known, the more the space of consistent, multiplicity-producing theories contracts. What remains is more exacting, more spare, and more in need of conceptual hygiene. The idea of many universes is not strengthened by rhetoric. It is strengthened when measures avoid paradox, when vacua needed for eternal behavior are derivable rather than assumed, when selection effects are unavoidable rather than convenient, when every step that leans on inference is pinned to a datum somewhere in the microwave sky, the web of galaxies, the bending of light, or the steadiness of unitarity. Night over deserts and plateaus remains clear. Telescopes keep their long vigil, superconducting circuits murmur in shielded rooms, keyboards clatter out regulators for infinities that otherwise will not yield. The mystery deepens without dissolving. It becomes a set of coupled obligations, to count only what can be counted without sleight of hand, to weigh only what a rule can weigh without contradiction, to speak only what a horizon allows without pretending it is not there. In that discipline, how many universes exist ceases to be a provocation and becomes a program. The escalation is the work itself, sharper instruments, stricter arguments, and a willingness to be told, by silence or by signal, where the line between this universe's knowable edges and the rest of reality actually lies. The landscape of explanation opened like a fan. Each spoke began with equations and ended in metaphors that risked sounding larger than the sky, yet each stayed tethered to a demand: predict something, or at least constrain the manner in which the cosmos can be many. The mystery of number, how many universes exist, could not be settled by counting. It required categories. Theories supplied them, each a grammar for plurality. The first category was the simplest and the least scandalous: a cosmos so large that horizons were provincial. Inflation, even in its modest, non-eternal guise, drives space to expand faster than light can knit it together, leaving behind an effectively boundless expanse. In such a universe, call it level I, identical laws rule everywhere, but initial conditions vary beyond any one Hubble volume. Regions separated by more distance than light has had time to travel are not exotic realms. They are distant neighborhoods with different arrangements of the same ingredients. Statistical repetition becomes inevitable across that immensity. There exists, unimaginably far away, a patch of sky where microwave ripples line up almost as they do here, and another where a quasar flickers in a pattern that would feel eerily familiar. The plurality here is geographic, not ontological. Many domains, one physics. If how many is asked in this register, the answer approaches uncountably many, only because size refuses to be domesticated. The test is discipline in the statistics, flat spatial curvature, a near, scale-invariant spectrum of primordial fluctuations, a cosmos whose properties do not betray edges. Each new constraint on curvature and isotropy keeps level I alive by refusing to close the room it requires. A sharper plural enters with level II, eternal inflation and the notion that physics at low energy can differ from place to place. In high-energy frameworks, string theory most prominently, vacua are not points but a landscape, an unruly atlas of metastable states distinguished by how extra dimensions are compactified, by which symmetries fracture, by which fluxes thread microscopic cycles. Each vacuum begets an effective world with its own constants. Eternal inflation supplies the engine. Quantum fluctuations keep some regions inflating while others slew off into pockets that cool and ignite, each pocket sealed from its siblings by ever-growing space between them. If the landscape is vast, almost every consistent low-energy recipe occurs somewhere. If eternal inflation persists, nearly all of them occur endlessly often. How many becomes a distribution problem, and why this set of numbers becomes environmental. Observers arise in those pockets where parameters tolerate chemistry, stars, and time. The small, positive vacuum energy measured in the present cosmos, so much smaller than naive quantum estimates that arithmetic alone groans, lands softly under this view. In an ensemble where vacuum energies vary, the vast majority of observers reside in domains where structure barely manages to form before accelerated expansion overwhelms it. The argument is not a proof, it is a claim about typicality. Its science lies in whether the landscape exists and whether eternal inflation samples it as advertised. Its risk lies in confusing selection, effects with explanations when both may be required. A perpendicular road enters not by enlarging space, but by refusing to amputate possibilities. Level III is Everett's plain reading of quantum theory. Unitary evolution is never interrupted. Measurement is not a theft of options, but a branching of them. Decoherence renders the branches effectively non-communicating by bleeding phase information into the environment, and classicality emerges as records that persist. Outcomes coexist, not as ghosts but as mutually inaccessible histories. The plurality here nests inside any cosmos, inflated or not. It overlays level I and level II rather than competing with them. If a detector clicks in one branch, its twin remains silent in another, and each branch contains an experimenter with a consistent notebook. Many worlds is not an additional machinery, it is a refusal to add collapse. Its empirical content sits in the sturdiness with which unitary dynamics have survived every attempt to find a fault. The question, how many, inherits a new dimension. The count increases not only across space, but across outcomes. The test is subtle. Interpretations do not leave fingerprints on data already explained by the same dynamics. The argument for level III rests on economy and coherence, on whether adding collapse is a higher cost than accepting branching. Beyond these tiers lies a proposal that trades humility for closure. Level IV, the wager that reality is mathematics, full stop. In this view, any self-consistent mathematical structure exists as a universe. The ensemble is not a set of regions within a spacetime, nor a set of quantum branches within a universal wave function. It is the library of structures themselves, each with its own rules and entities, each instantiated by consistency. The attraction is a single axiom that swallows why these equations, by denying privilege to any. The hazard is radical unobservability. If every consistent structure exists, the only observable statement becomes anthropic, Observers find themselves in structures that support observers. This is speculation stretched until it is thin. Its value, if any, is philosophical pressure on the lower tiers to be honest about what counts as explanation. Not all roads to plurality are inflating or branching. Some imagine universes budding from quantum events that reshape spacetime itself. In semi-classical gravity, a false vacuum decays by tunneling. Coleman. DeLucia bubbles nucleate and expand, walls racing outward near light speed, the interior reheating with new constants. Eternal inflation already uses such decays as the gears of its proliferation. But even without a global inflating background, vacuum decay can seed isolated transitions that alter the rules locally. A more audacious suggestion treats de Sitter expansion as a factory for baby universes. Rare fluctuations birthing causally disconnected pockets whose arrows of time reset. Again, the currency is plausibility, not demonstration, and the promise is an avenue by which universes beget universes without a singularity that must be legislated from beyond. Quantum cosmology provides still another stage. Path integrals over geometries, a sum over histories where spacetime itself fluctuates, offer boundary proposals that weight entire universes by amplitudes rather than by classical initial conditions. The no-boundary idea imagines a smooth cap to time where before the Big Bang is a change of signature rather than a wall. A tunneling proposal imagines the universe emerging from nothing in a probabilistic sense. These ideas do not enumerate universes so much as assign likelihoods to classes of them. How many becomes with what amplitude, and the test is consistency with the observed universe's smoothness, curvature, and spectrum of initial fluctuations. Their mathematics is crisp, their ontology is quieter, their empirical tie is indirect but not imaginary, since amplitudes bias which kinds of universes are expected to be observed by creatures inside them. Competing frameworks of quantum gravity enter with their own biases toward or away from multiplicity. In string theory, the landscape furnishes a natural level II engine, but recent conjectures question the existence of fully stable de Sitter vacua. If such vacua are scarce or forbidden, eternal inflation's habitat narrows. Conversely, de Sitter spaces with negative curvature enjoy a holographic accounting. Boundary conformal field theories encode bulk gravity, which hints that some multiverse questions could be recast as statements about ensembles of quantum theories without gravity. Whether that holography can be exported to accelerating universes remains contested. Loop quantum cosmology, quantizing spacetime geometry itself, replaces the classical Big Bang singularity with a bounce in some models. A sequence of bounces can look like a cyclical history or a chain of distinct macroscopic epochs. Here, multiplicity is temporal succession rather than spatial parallelism or quantum branching, and the test is whether quantum corrections leave imprints in the microwave background's largest-scale modes or in primordial gravitational waves. Across these approaches, the same ethic persists. Speculative structure must produce calculable, if slender, footprints. Speculation also visits biology's doorstep and retreats with more questions than answers. Cosmological natural selection imagines that black holes seed new universes, with parameters slightly mutated. Universes that are good at making black holes become more common in the ensemble, and parameters drift toward that fecundity. The poetry is strong, the predictions are delicate. If a small change in constants would produce more black holes than observed, the idea would falter. If not, it remains a parable of selection rather than a theorem. Its worth within this inquiry lies in showing how even radical plurality can be yoked to falsifiable nudges, however faint. None of these frameworks escapes the discipline of measure. In level II, probabilities over bubbles require regulators. In level III, branch weights follow squared amplitudes but must survive decoherence's bookkeeping. In quantum cosmology, amplitudes weight entire geometries. A consistent theory of how many must say not only what exists, but how to weigh what exists when everything is abundant. Proposals range from global cutoffs, slicing the inflating spacetime by time parameters, to local prescriptions, following single geodesics or causal patches, to stationary distributions that claim independence from initial conditions. Each proposal is judged by hygiene, avoid paradoxes, suppress freak observers conjured from thermal noise, reproduce observed regularities without presuming them. Progress here is intellectual carpentry, not spectacle, yet without it the edifice leans. Throughout, the observational anchors remain the same, and every theory must tie lines to them. A nearly Gaussian, slightly tilted spectrum of primordial perturbations favors slow-roll inflation, but disfavors flamboyant multi-field fireworks unless the fireworks are tuned to be quiet. Upper limits on primordial B-mode polarization press down the energy scale of inflation and prune models with large field ranges, models that otherwise would have made eternality easy. Spatial curvature consistent with zero supports large, smooth inflating domains, but does not compel them. Limits on isocurvature modes and non-Gaussianity hem in the number of active fields during the earliest moments. Late-time acceleration insists that vacuum energy, or something masquerading as it, exists, nudging eternal pictures toward de Sitter plateaus unless quantum gravity denies them. Every tightened constraint carves away branches of the speculative tree, leaving a thinner trunk that must carry more weight. Amid these architectures, a pattern emerges. Level I is an almost inevitable corollary of even modest inflation, and demands little beyond bigness. Level II turns inflation and high-energy theory into an engine of diversity, and asks for a calculus to tame infinities. Level III turns quantum mechanics into an ontology, and asks for the courage to live without collapse. Level IV relocates reality to mathematics, and asks for a philosophy of observation that many find too lean. Auxiliary ideas, vacuum decay, baby universes, quantum cosmology's boundary conditions, bounces in loop dynamics, modify which tiers are populated and how. None alone answers the question. Together they define what an answer could mean. The work ahead is not to crown a champion, but to triangulate. A detection of primordial gravitational waves at a specific amplitude would lift certain inflationary potentials, and with them, the plausibility of eternality. A crisp non-Gaussian signature would point toward extra fields, changing the texture of the landscape and the topology of branching. A decisive exclusion of long-lived de Sitter states in quantum gravity would shear the ensemble back to humbler multiplicities. A coherent, paradox-free measure would turn a gallery of possibilities into a predictive machine, or else expose the notion of typicality as misapplied to an unbounded cosmos. Even null results are instructive. Each absence is a map of where many universes could have left marks but did not. In the end, the speculative architectures are not decorations around a settled core. They are the scaffolding on which the core stands while being tested. Each preserves a different virtue: continuity of quantum law, universality of mathematics, fecundity of inflation, humility of selection effects. And each pays a different cost: untestability, measured dependence, ontological extravagance, philosophical unease. The count of universes, if count there is, hides behind these trades. The theories do not agree on a numeral. They agree on a posture. Reality may be larger than the lantern of observation, and yet legitimate science can still stalk its edges by demanding consistency, by squeezing models with data, and by refusing beauty that makes no wagers. Under that discipline, speculation ceases to be drift and becomes a compass, pointing not to a tally, but to the kinds of worlds that can exist and still explain why a world like this one is able to ask. The instruments are quiet until the sky speaks. Steel and carbon fiber, cryostats and mirrors, algorithms and patience, each waits for the night to open. The question, how many universes exist, will not answer to rhetoric. It bends only to measurement. So the field builds lanterns and holds them to the oldest light, to the faint curling of polarization, to the way matter tugs on images of distant galaxies, to the tempo of standard rulers freezing into the web. The work is not a single experiment but a choreography. Deserts, plateaus, and an L2 halo. Copper traces buried in superconducting wafers, pipelines that distrust their own exuberance. The program is fidelity, and the wager is that enough fidelity becomes evidence. On the polar plateau and in the Atacama's thin air, the search for primordial B modes. The curl pattern inflation could have stamped on the cosmic microwave background, has become a long, ascetic pilgrimage. The Bicep Keck program keeps vigil at the South Pole, widening its frequency coverage and deepening exposure so that foregrounds can be tamed rather than wished away. Its most recent combined analyses press the tensor-to-scalar ratio to the low few hundredths, a constraint that has already felled broad families of inflationary potentials and taught theorists to be austere. The next maps, quietly named and obsessively versioned, promise further weight, but the ethics of the search remain the same. Many frequencies, shared sky, cross-checks, no single claim without a chorus behind it. North of the pole, in Chile's dry heights, the Simons Observatory turns on a suite of small aperture telescopes for degree-scale polarization and a newly installed 6-meter large aperture telescope for arc-minute mapping. First Light Mars in late February was not a headline so much as a handshake. Optics aligned, cryogenic steady, the system listening. What follows is a campaign in multiples. Multiple frequencies to catch and subtract dust, multiple seasons to defeat noise, multiple collaborations to delens the sky, stripping away the lensing B modes induced by the intervening web to expose any primordial curl beneath. If B modes exist above vanishingly small levels, this is one of the places they will be coaxed into the open. Between those ground campaigns, satellite legacies continue to anchor the compass. Planck's last word on the microwave background, full sky temperature and polarization, lensing maps, and the harmonics that ring like a young universe's drum, still defines the standard model's centerline. Against that baseline, experiments try to add curl without adding confusion. The logic is incremental. An upper limit is not silence. It is a shrinking stage on which theories are allowed to perform. The Atacama Cosmology Telescope's Dr. 6 lensing results, with percent-level precision, show a growth of structure consistent with a lambdictum cosmos projected from the CMB's surface of last scattering, knitting early and late with a firmness that leaves little slack for extravagant departures. Yet the oldest light is not the only ledger. A second witness stands in the geometry of large-scale structure, how galaxies and quasars arrange themselves, and how their separations whisper the size of an ancient sound wave. The dark energy spectroscopic instrument DAISY, now into multi-year depth, has released baryon acoustic oscillation measurements that treat the sky as a ruler factory. By reading that ruler at many epochs, DAISY sketches the expansion history with sub-percent poise, feeding joint inferences that test the smoothness of dark energy and the coherence of the standard picture when stitched to CMB priors. Its Dr. 2 suite, spread across papers like facets, is not a verdict but a pressure, on curvature, on late-time acceleration, on neutrino masses, and on any proposal that would let universes be many without breaking the one at hand. From space, a new cartographer has joined the work. Euclid, launched to map the dark universe with weak lensing and galaxy clustering, has issued its first public trove, images, catalogs, and early science that demonstrate the machine's intent. Strong lensing arcs bend across pristine deep fields. Pipelines learn to trace shear in ranks of distant galaxies so that the invisible mass between can be weighed in projection. The cosmological harvest will be measured in years, not days, but the path is marked. Lens dark matter in the billions of shapes, measure clustering over a third of the sky, test whether gravity's rules feel the same across cosmic time. Closer to the ground, but aimed at the same horizon, the Vera C. Rubin Observatory has shown its first images. A 3.2 gigapixel eye and an 8.4-meter mirror promise a decade-long time-lapse of the southern sky, with every patch revisited in a rhythm that turns transients into statistics. For cosmology, Rubin's weak-lensing shear maps and supernova light curves will become a second backbone, cross-checked against Euclid's space-sharp images and Dacey's spectroscopic rulers. For philosophy, the cadence becomes a meditation on typicality, what it means to be a single history when the sky records so many variations on a theme. None of these frameworks escapes the discipline of measure. In level II, probabilities over bubbles require regulators. In level III, branch weights follow squared amplitudes but must survive decoherence's bookkeeping. In quantum cosmology, amplitudes weight entire geometries. A consistent theory of how many must say not only what exists but how to weigh what exists when everything is abundant. Proposals range from global cutoffs, slicing the inflating spacetime by time parameters, to local prescriptions, following single geodesics or causal patches, to stationary distributions that claim independence from initial conditions. Each proposal is judged by hygiene. Avoid paradoxes, suppress freak observers conjured from thermal noise, reproduce observed regularities without presuming them. Progress here is intellectual carpentry, not spectacle, yet without it the edifice leans. Throughout, the observational anchors remain the same, and every theory must tie lines to them. A nearly Gaussian, slightly tilted spectrum of primordial perturbations favors slow-roll inflation, but disfavors flamboyant multi-field fireworks unless the fireworks are tuned to be quiet. Upper limits on primordial B-mode polarization press down the energy scale of inflation and prune models with large field ranges, models that otherwise would have made eternality easy. Spatial curvature consistent with zero supports large, smooth inflating domains, but does not compel them. Limits on isocurvature modes and non-Gaussianity hem in the number of active fields during the earliest moments. Late-time acceleration insists that vacuum energy, or something masquerading as it, exists, nudging eternal pictures toward de Sitter plateaus unless quantum gravity denies them. Every tightened constraint carves away branches of the speculative tree, leaving a thinner trunk that must carry more weight. Amid these architectures, a pattern emerges. Level I is an almost inevitable corollary of even modest inflation, and demands little beyond bigness. Level II turns inflation and high-energy theory into an engine of diversity, and asks for a calculus to tame infinities. Level III turns quantum mechanics into an ontology, and asks for the courage to live without collapse. Level IV relocates reality to mathematics, and asks for a philosophy of observation that many find too lean. Auxiliary ideas, vacuum decay, baby universes, quantum cosmology's boundary conditions, bounces in loop dynamics, modify which tiers are populated and how. None alone answers the question. Together they define what an answer could mean. The work ahead is not to crown a champion, but to triangulate. A detection of primordial gravitational waves at a specific amplitude would lift certain inflationary potentials, and with them, the plausibility of eternality. A crisp non-Gaussian signature would point toward extra fields, changing the texture of the landscape and the topology of branching. A decisive exclusion of long-lived de Sitter states in quantum gravity would shear the ensemble back to humbler multiplicities. A coherent, paradox-free measure would turn a gallery of possibilities into a predictive machine, or else expose the notion of typicality as misapplied to an unbounded cosmos. Even null results are instructive. Each absence is a map of where many universes could have left marks but did not. In the end, the speculative architectures are not decorations around a settled core. They are the scaffolding on which the core stands while being tested. Each preserves a different virtue: continuity of quantum law, universality of mathematics, fecundity of inflation, humility of selection effects. And each pays a different cost: untestability, measured dependence, ontological extravagance, philosophical unease. The count of universes, if count there is, hides behind these trades. The theories do not agree on a numeral. They agree on a posture. Reality may be larger than the lantern of observation, and yet legitimate science can still stalk its edges by demanding consistency, by squeezing models with data, and by refusing beauty that makes no wagers. Under that discipline, speculation ceases to be drift and becomes a compass, pointing not to a tally, but to the kinds of worlds that can exist and still explain why a world like this one is able to ask. The instruments are quiet until the sky speaks. Steel and carbon fiber, cryostats and mirrors, algorithms and patience, each waits for the night to open. The question, how many universes exist, will not answer to rhetoric. It bends only to measurement. So the field builds lanterns and holds them to the oldest light, to the faint curling of polarization, to the way matter tugs on images of distant galaxies, to the tempo of standard rulers freezing into the web. The work is not a single experiment but a choreography. Deserts, plateaus, and an L2 halo. Copper traces buried in superconducting wafers, pipelines that distrust their own exuberance. The program is fidelity, and the wager is that enough fidelity becomes evidence. On the polar plateau and in the Atacama's thin air, the search for primordial B modes, the curl pattern inflation could have stamped on the cosmic microwave background, has become a long, ascetic pilgrimage. The Bicep Keck program keeps vigil at the South Pole, widening its frequency coverage and deepening exposure so that foregrounds can be tamed rather than wished away. Its most recent combined analyses press the tensor-to-scalar ratio to the low few hundredths, a constraint that has already felled broad families of inflationary potentials and taught theorists to be austere. The next maps, quietly named and obsessively versioned, promise further weight, but the ethics of the search remain the same. Many frequencies, shared sky, cross-checks, no single claim without a chorus behind it. North of the pole, in Chile's dry heights, the Simons Observatory turns on a suite of small aperture telescopes for degree-scale polarization and a newly installed 6-meter large aperture telescope for arc-minute mapping. First Light Mars, in late February, was not a headline so much as a handshake. Optics aligned, cryogenic steady, the system listening. What follows is a campaign in multiples. Multiple frequencies to catch and subtract dust, multiple seasons to defeat noise, multiple collaborations to delens the sky, stripping away the lensing B modes induced by the intervening web to expose any primordial curl beneath. If B modes exist above vanishingly small levels, this is one of the places they will be coaxed into the open. Between those ground campaigns, satellite legacies continue to anchor the compass. Planck's last word on the microwave background, full sky temperature and polarization, lensing maps, and the harmonics that ring like a young universe's drum, still defines the standard model's centerline. Against that baseline, experiments try to add curl without adding confusion. The logic is incremental. An upper limit is not silence. It is a shrinking stage on which theories are allowed to perform. The Atacama Cosmology Telescope's Dr. 6 lensing results, with percent-level precision, show a growth of structure consistent with a lambdictum cosmos projected from the CMB's surface of last scattering, knitting early and late with a firmness that leaves little slack for extravagant departures. Yet the oldest light is not the only ledger. A second witness stands in the geometry of large-scale structure, how galaxies and quasars arrange themselves, and how their separations whisper the size of an ancient sound wave. The dark energy spectroscopic instrument DAISY, now into multi-year depth, has released baryon acoustic oscillation measurements that treat the sky as a ruler factory. By reading that ruler at many epochs, DAISY sketches the expansion history with sub-percent poise, feeding joint inferences that test the smoothness of dark energy and the coherence of the standard picture when stitched to CMB priors. Its Dr. 2 suite, spread across papers like facets, is not a verdict but a pressure, on curvature, on late-time acceleration, on neutrino masses, and on any proposal that would let universes be many without breaking the one at hand. From space, a new cartographer has joined the work. Euclid, launched to map the dark universe with weak lensing and galaxy clustering, has issued its first public trove, images, catalogs, and early science that demonstrate the machine's intent. Strong lensing arcs bend across pristine deep fields. Pipelines learn to trace shear in ranks of distant galaxies, so that the invisible mass between can be weighed in projection. The cosmological harvest will be measured in years, not days, but the path is marked. Lens dark matter in the billions of shapes, measure clustering over a third of the sky, test whether gravity's rules feel the same across cosmic time. Closer to the ground, but aimed at the same horizon, the Vera C. Rubin Observatory has shown its first images. A 3.2 gigapixel eye and an 8.4-meter mirror promise a decade-long time-lapse of the southern sky, with every patch revisited in a rhythm that turns transients into statistics. For cosmology, Rubin's weak-lensing shear maps and supernova light curves will become a second backbone, cross-checked against Euclid's space-sharp images and Dacey's spectroscopic rulers. For philosophy, the cadence becomes a meditation on typicality, what it means to be a single history when the sky records so many variations on a theme. Ahead, the Nancy Grace Roman Space Telescope sharpens the plan for a wide field, space-quality lensing and supernova survey. Roman's camera will take in swaths of sky 2 orders of magnitude larger than Hubble's with equivalent sharpness, turning the dark energy program into a single, coherent exposure. Its schedule is public and cautious, no later than May 2027, with efforts to steal time back if engineering allows, and the rationale is relentless. Reduce systematics by moving above the atmosphere, calibrate distances with a ladder that creaks less, and combine with ground surveys to triangulate the late universe's temperament. These are the lanterns for the cosmic scales that inflation and dark energy care about. But the inquiry also presses at the quantum seam where multiplicity, if it lives, might be an interpretation rather than an expanse. In laboratories, unitary dynamics keep surviving new regimes. Massive molecules are marched through interferometers. Superconducting circuits are bulleted into sewer positions with lifetimes long enough to count. Mechanical resonators flirt with quantum behavior visible to the eye's proxy. No device has pried apart branches, and none is expected to. Decoherence ensures that intervention grows exponentially impossible with scale. The point is humbler. Each confirmation that Schrödinger's equation holds where it had no right to be comfortable shifts the burden of proof toward minimalism, toward leaving quantum theory uncollapsed and letting multiplicity, if one accepts it, reside in the bookkeeping of entanglement rather than in extra assumptions grafted on top. At lower radio frequencies, a different frontier listens for the universe before the first stars ionize the fog. The hydrogen epoch of reionization array and its peers chase a spectral shadow, the 21-centimeter signal from neutral hydrogen during the first billion years. Foregrounds are ferocious. The calibration is a discipline of subtraction and humility. Even so, upper limits have tightened, and with them, models of how the first light heated and reshaped the intergalactic medium. A definitive detection would turn when into how, fixing the timeline of structures dawn and giving inflation another surface to cast its shadow. The harvest is still ahead, but the field's patience has already narrowed theory's playground. Gravity itself offers a chorus in multiple registers. At nanohertz frequencies, pulsar timing arrays now report a common red process with the angular correlations predicted by general relativity, the grave murmur of a gravitational wave background, most likely the sum of supermassive black hole binaries settling their orbits across cosmic time. Inflationary relics at those periods are disfavored, but the detection proves a principle. The universe hums in backgrounds, and the right instrument can hear them. As the background is characterized and anisotropies are mapped, any residual room for exotic early universe sources will be fenced with increasing confidence. If the B-mode pilgrimage needed a reminder that progress is mortal, it received one, an ambitious Stage 4 CMB project, designed to push R to the edge of 10.3, lost federal backing in mid-2025. The science case remains. The community pivots to upgrades of existing facilities and to international partners. Instruments can be cancelled, evidence cannot. The path forward becomes more modular. Deepen with Bicep Keck and South Pole companions. Accelerate mapping with the Simons Observatory. Delens with cross surveys. And let Roman, Euclid, and Rubin close ranks on the late universe that any early universe story must pass through. What then counts as ongoing testing when the subject is plurality? First, prune inflation. Every notch downward in the tensor-to-scalar ratio is a cut through parameter space. Certain large-field models become implausible. Others survive, but only if they generate eternality with finer gears. Delensing becomes a shared discipline, using high-resolution maps of the intervening structure to peel away lensing B-modes. An enterprise that depends on cross-correlating experiments rather than on any one alone. Second, weigh the late universe as if one's life depended on it. Dacey's rulers, Euclid's and Rubin's shears, Roman's space-quiet distances, all conspire to test whether the expansion is as featureless as a constant lambda demands, or whether time has texture. Any deviation from the most boring acceleration is a clue about the vacuum and its landscape. Third, insist on hygiene in infinity. Theorists continue to tame measures for eternal inflation, not with slogans, but with regulators that avoid paradoxes and reproduce observed regularities without smuggling them in. In parallel, quantum cosmology refines boundary proposals into amplitudes that can be compared with the smoothness and tilt of the initial fluctuation spectrum. There is also a negative art to the program, constructing non-detections with enough precision that they hurt. Searches for signatures of bubble collisions in the microwave background, circles, disks, step-like modulations, have so far returned null results, but the templates and pipelines they developed have value beyond the chase. They demonstrate that ideas born in the high country of theory can be led down into the valley where data live, and that even a no can do honest work. The same ethic holds for topology searches in the microwave sky and for curvature fits pressed closer to zero. Absence, stated carefully, is a boundary of the possible. The cadence is slow because it must be. Each new survey is a decade. Each new instrument is a generation of students and a book of failure modes bound in the back of their notebooks. But accumulations become thresholds. A true detection of primordial B modes at a convincing level would lift the energy scale of inflation into view, and in many models, make eternal behavior a live default rather than a rumor. A crisp non-Gaussian fingerprint would point to extra fields in the early swell, altering what a multiverse would look like if it exists at all. A convergence among Dacey, Euclid, Rubin, and Roman on exactly lambda acceleration would quiet some landscapes and sharpen others. A measured drift would light new corridors through theory. And if the nanohertz gravitational wave background yields anisotropies mapped with the same clarity as the microwave sky, even a song most likely sung by black hole binaries will become a tool for ruling out the stray exotic choir. At the end of each observing run, the instruments rest and the data do not. Pipelines blind their analysts against their own wishes. Teams trade and check. Public releases invite the world to try to break the result. This is not spectacle. It is the plain courage of a field that understands what it is asking. The question of how many universes exist is a question about whether theories that multiply reality can be nailed to observables in this one. The answer, if it comes, will not arrive as a census but as a narrowing. Fewer inflationary potentials, fewer late-time freedoms, cleaner measures over infinity, and a sky whose stubborn refusal to lie becomes the most generous thing about it. Night gathers on the high plateaus, and the instruments fall silent, but the question remains lodged in the air like frost. How many universes exist? The arithmetic of the cosmos has been stretched until it touches the philosophy of meaning, and still, the sky refuses to score an ending. What began as a census has become a meditation on what is being counted, and on whether number is even the right verb for reality. If there are many, the tally drifts toward infinity in more than one sense, across space, across quantum branches, across possible laws. If there is one, it is a singularity in a different key, a world whose parameters arrive as unargued facts, a poem that does not rhyme with anything else. Science does not ordinarily traffic in metaphysics, yet cosmology drags it along like a shadow. Plurality forces old words to work harder. Explanation can be derivation from principle, as when a spectrum's tilt follows from a field's slow roll. It can also be selection from an ensemble, as when only in certain pockets do galaxies congeal before acceleration tears them apart. Prediction can be a crisp probability, measured against a finite set of trials. In an unbounded ensemble, it becomes a theory of typicality, disciplined by a measure that dares to say what counts as most. The danger is sentimentality, using the many to excuse the unexplained. The remedy is hygiene. Require that every plurality come with rules for weighing possibilities, and that those rules avoid paradox and match the sky's indifference to our preferences. Horizon and decoherence are not only obstacles, they are tutors. The horizon teaches modesty. There are regions whose light will never arrive, not because technology is poor, but because geometry is cruel. Decoherence teaches realism. There are branches that will never interfere again, not because interpretation is timid, but because entanglement is voracious. Between these tutors, the method is refined. Instruments must speak for the one universe that can be seen. Theory must carry the burden of inference without presuming the conclusion. The discipline is simple to say and difficult to live by. Make every speculative extension answerable, at least in principle, to some imprint in the only sky that sends photons. Einstein's equations gave permission for a dynamic cosmos, and the observation seized it. In that gift lies a permanent lesson. Geometry is not a stage but a participant. The vacuum is not empty but persuasive. Time is elastic enough to make beginnings ambiguous. Hawking's work at the edge of singularities and the rim of black holes press the point further. Horizons possess thermodynamics. Information resists oblivion even where intuition would bury it. Those results do not prove or disprove a multiverse. They widen the sense of what a universe can be. If spacetime can radiate and store memory at its boundaries, if entropy can be counted on horizons, then origins and multiplicity are not contradictions to be argued away. They are regimes waiting for a language that can hold them both without remark. The arrow of time gives the question its human color. Entropy climbs, structure loosens, memories lean on gradients that will one day flatten. Inflation explains why distant regions agree on their temperature and why space is so nearly flat. It does not cheaply explain why the early cosmos was so extraordinarily low in entropy that an arrow could be drawn at all. In a plural picture, one can say that most observers arise where such an arrow exists, because minds depend on memory and memory depends on irreversibility. That answer is not dismissible. It is also not complete. It moves the question from why this improbable start to why an ensemble in which improbable starts are generative. To live with that translation is to accept that some explanations in cosmology now braid physics with conditional reasoning, and that the braid must be tight enough to survive contact with data. Identity, once a private concern of minds, becomes a coordinate in the problem. If space is sufficiently large, there are regions so distant that configurations of matter nearly copy this neighborhood. If quantum evolution never collapses, there are histories that match this record until a measurement branches them apart. Which copy is this? Sounds like a parlor trick until typicality demands an answer. Self-locating information. This position in space, this time in expansion, this notebook with these entries, enters the likelihoods that test theories of the whole. The reflection need not diminish importance. It simply relocates it. Significance is not conferred by uniqueness of placement, but by coherence of pattern. A melody is not less meaningful because it repeats. It is music because repetition and variation make sense together. Many fear that multiplicity thins meaning, that an ensemble of worlds devalues anyone. The record of science suggests the opposite. The Copernican step, moving Earth from center to periphery, did not empty the world, it gave it a firm sky to stand under. The discovery that stars are suns did not cheapen this one, it gave thermodynamics a universal stage. If there are many universes, this one does not become smaller, it becomes located. Location is not humiliation, it is context. Within context, duty sharpens. Ethics does not dilute in a multiverse. On the contrary, responsibility localizes. Suffering and beauty are not distributed abstractions, they are particular and immediate. A cosmos large beyond appeal is no excuse to be trivial where one stands. Theories that multiply worlds sometimes sound like escapes, but their best versions are austere. Many worlds deletes collapse, not to dazzle but to stop adding unobserved rules. Inflation solves old puzzles, not by magic, but by dynamics that can be calculated and injured by data. Even the most lavish proposal, the identification of reality with mathematics, begins with the vanilla insistence that what is not contradictory need not be privileged by being singular. Such asceticism is a mood as well as a method. It asks for parsimony in assumptions and generosity in consequences. It holds beauty at arm's length until numbers bring it near. In that ethos, plurality is not excess, it is frugality's price. The boundary at the beginning remains a fire that does not cool. A theorem shows that expansion, on average, cannot be extended forever into the past. Inflation may be eternal to the future, yet still confront a cliff when the film is run backward. Quantum cosmology answers with amplitudes over geometries, no boundary caps and tunneling proposals that round off the singular. These are not slogans, they are integrals. They will earn their keep only if they illuminate why this universe exhibits the smoothness and the tiny, nearly scale-free ripples that the afterglow records. Whether the first moment is a boundary in time or a change of description, the presence of a beginning is not diminished by multiplicity. It is clarified by it. Even if many begin, each has a beginning, and the grammar of beginnings remains a frontier where physics and philosophy share the same untranslated words. The future of the question is patient. Ground telescopes will keep combing polarization for the curl that inflation might have left, while satellites and survey cameras weigh the late universe until its acceleration either confesses to constancy or deviates into narrative. Particle experiments and tabletop interferometers continue to test unitarity where classicality once seemed safe. Theorists will keep carving measures that count without lying, and models of high-energy physics that grant or deny long-lived de Sitter plateaus. None of these labors guarantee a census. They guarantee a tightening, fewer ways to be wrong, a thinner set of ways to be right. In that tightening, the plurality question becomes less a speculation and more a parameter, not a rumor on the edge of knowledge, but a knob that theory must set and that observation can, at least indirectly, constrain. If the answer turns out to be a disciplined, many, the shock will be philosophical rather than practical. Horizons will not shrink, branches will not interfere, constants in this pocket will remain the ones biology and culture have already learned to lean on. What will change is the sense of explanation's endpoint. The temptation to chase a single, necessary reason for each number will yield to an ensemble in which reasons are distributions and understanding, is a statement about where in that distribution observers typically awaken. If the answer is 1, the word will not mean small. It will mean that contingency is deeper than hoped, and that the cosmos is a particular solution to equations that might have permitted others but did not realize them. Either answer requires humility, about what is deducible, about what is inferable, about what must be simply learned from the world without guarantee of metaphysical consolation. There is a gentler thought beneath the arithmetic. The universe, whether alone or among many, has arranged conditions under which matter can remember, question, and refuse cheap closure. Carbon, forged in the cores of stars, has become biography. Starlight, stretched by expansion into microwaves, has become evidence. Geometry, once a drawing, has become a cause. These transformations do not need multitudes to be astonishing. They need time and temperature and the stubborn consistency of laws. If multiplicity is true, it tells where these transformations are common. If uniqueness is true, it tells how rare and therefore how precious they are. In both cases, value is informed, not erased. At the end, the camera returns to the night. The Milky Way lays a broken river of light across deserts and oceans. The microwave sky, invisible to eyes, keeps its even hush. Galaxies, so many that language abandons exactness, drift on hills of invisible mass as expansion plays its slow music. A narrator might wish to close with certainty, but the honest cadence is quieter. There is work to do, maps to refine, signals to peel from dust, theories to starve until only the necessary calories remain. There is also a sentence that no measurement will delete. The mystery has earned its dignity. To ask how many universes exist is to ask what kind of thing reality is, and to accept that method, not desire, will decide how far the answer can travel. The night hums with this restraint. Somewhere a detector cools. Somewhere else a blackboard fills with regulators for infinities that will not behave. In another room, a pipeline blinds itself against its authors, wishes and waits for a result it will not trust until an independent eye agrees. In all those places, one world is being measured well enough to speak for others, if others there are. If the cosmos is many, the chorus is vast. If it is one, the solo is real. Either way, the music continues, and the patience to hear it remains the most human thing under the sky.